So we're going to go through and do a full analysis on this two-variable data set, top to bottom. So what I have for you there is the data set shown here was gathered from new employees of the Durham Tim Hortons throughout 2018. The employees were asked every Monday how many Timbits they'd eaten during the shift and paid for, of course. So we have the number of weeks that they've been working on the job because they're new employees. The first one's only been there a week and the second one's been there for 4 weeks. And then how many Timbits they eat per shift. Now if you look at it, you might be able to see that as their work experience increases, the number of Timbits does seem to decrease. So we should be expecting a negative correlation coefficient and a negative slope on our line of best fit. So with that said, we need to get to it. So the first thing we're going to have to do is get our x squared, y squared, and xy columns. So I'm going to work on that with my fast forward button. So now that we have the typical or the standard deviation, the average values for both the number of Timbits consumed and the number of weeks of experience, we can take those values and we can determine what a typical value would be. So for x, take the x average and we will add and subtract one standard deviation in order to get that typical value range. So for this particular set, my average x is 2.1 and my standard deviation is 0.943, right, which gives us a range of 2.1 minus 0.943 is 1.157, and 2.1 plus 0.943 is 3.043. And if we were to take that information and phrase it in the form of a sentence, our x values were the number of weeks that these new employees had been working. So a typical employee has been working between 1.157 and 3.043 weeks. So let me write that down for you. He has been working between 1.157 and 3.043 weeks. So if we do the same for y, take the y average and add and subtract a standard deviation. My average y was 6.1 and the standard deviation on that was 2.773, giving us a range of 6.1 minus 2.773 is 3.327, and 6.1 plus 2.773 is 8.873. If I were to frame this one as a sentence, the y value was the number of Timbits eaten per shift. So these new employees are eating between 3.327 and 8.873 Timbits per shift. A typical employee, typical new employee is eating between 3.327 and 8.873 timbits per shift. So I'm going to record these ranges because we will need them later when we do extrapolations and interpolations to decide whether we've gone beyond this value and beyond this value so that we're in the outside of a typical range. Once I've got that done, we're going to talk about the outlier boundaries. So to establish the outlier boundaries for my x values and y values, I'm going to have to take the average value and step up 3 standard deviations and down 3 standard deviations in order to find which data points could justifiably be removed from my set. So if I were to work on the x values, which are the number of weeks on the job, then I have the x average plus or minus 3 standard deviations of x. My x average, if I find it on here, is 2.1 plus or minus 3 standard deviation of x is 0.943. So if I were to take that and subtract 2.1 minus 3 times 0.943, I get negative 0.729. And if I do 2.1 plus 3 times 0.943, I get 4.929. So if I have any x value that is less than that number, or any x value that is greater than this number, I have discovered an outlier. So if I were to take that and phrase it as a sentence, I would be saying that any employee working fewer than negative 0.729 or more than 4.929 hours per week is an outlier. Okay. So once we've done it for x, we have to do it for y as well. So the y values would be the y average plus or minus 3 standard deviations of y. My y average is 2.1. That's not right. 6.1. So it would be 61 divided by 10. 6.1 plus or minus 3 times the standard deviation of y is 2.773. So if I were to subtract them, 6.1 minus 3 times 2.773 is negative 2.219. And if I add them, 6.1 plus 3 times 2.773 is 14.419. So again, any y value, that's number of timbits eaten per shift, any number of timbits less than this, or any number of timbits more than that would be considered an outlier. So if I were to phrase that as a sentence, any employee eating fewer than negative 2.219 or more than 14.419 timbits per shift is an outlier. So now that we've finished up all of the single variable analysis stuff, we can launch into the two variable stuff. Alright, so after all that work, we can start to plot this line onto our graph. Please note I had omitted the negative when I got the correlation coefficient, but I have fixed it since then. So the R value is negative 0.922. I've got a y-intercept here of 11.79, so that's about here. And in order to figure out where the line goes, I'm just going to pick a number out here. I'm going to pick a 5, and I'm going to plop it into my model here to see how far up and down on y I should be. So y is negative 2.710 times 5 plus 11.791. 2.71 times 5 is negative 1.75. So when x is 5, I should be at negative 1.75. That's problematic. It's not going to fit on my graph. So let's try that again. Let's go with 4. 11.791 minus 4 times 2.71, 0.951. So 4 and 0.951 is about here. So if I were to connect those dots, goes right through my set, which is always encouraging. So once you've established all this stuff, we need to go through and we need to interpret these values for the slope and the y-intercept. So what my line is telling me is that with 0 hours working, a typical employee would eat 11.791 timbits per shift. So what happens after that? Well, once they started working, you can see by the model, it's the trend that's in our model, that the number of timbits they eat per shift starts to decrease. And it starts to decrease at 2.710 timbits per hour worked. So with 0 hours working, a typical employee would eat 11.791 timbits per shift. The number of timbits decreases by -2.710 per hour worked. I'm just going to check what my data was. Oh, sorry. It's not number hour worked, it's per week on the job. So on to the extrapolation and interpolation section. If you were to ask yourself, using this particular model and that particular correlation coefficient, how many Timbits you would expect to be eaten by an employee with 4 weeks of experience? Well, 4 weeks of experience, this was our x value. So I'm going to take that 4, I'm going to put it into my model. 4 weeks experience plus 11.791. And I'm going to work that out. $11.791 2.71 times 4 gives me 0.951. So, in answer to this question, you would expect an employee with 4 weeks experience to be eating 0.951 Timbits per shift. Alright, so once you make an extrapolation or an interpolation, you have to have some comment on how reliable it is or how confident you feel in this result. So the first thing you should always check is your correlation coefficient. So for this one, we have a correlation coefficient of 0.922. Anything with a 0.9 is a very strong correlation. So I'm going to jot that down there. Very strong correlation. And then I'm going to check my outliers. So 4 weeks of experience, we had decided earlier that outliers were anything larger than 4.9. So this number of weeks experience, 4, is within the safe range. It is outside the typical range of weeks of experience, but not outside of the outliers. So I'm going to write down that it is outside typical, but inside outliers. Based on these 3 factors here, that I do have a very strong correlation and that it is inside the outliers, I'm fairly confident. The only question I have really is that it does lie outside of the typical values. Now it's up to you. You get to make a decision about this. How confident are you? In my opinion, I would say that this was a fairly reliable result, that 4 weeks of experience results in 0.951 Timbits eaten per shift, as according to this data that we collected. So, a new question. How many weeks of experience do you expect an employee to have if they are eating 6 Timbits per shift? 6 Timbits per shift. Timbits were y value. So I'm going to take my model and I'm going to park my 6 Timbits in for the y and then solve for the x with a little algebra. So 6 is negative 2.710x plus 11.791. Subtract this from both sides. And I get 6 minus 11.791 is negative 5.791. divide both sides. Divided by 2.710. It's me 2.137 if I round. So, phrased as a sentence, I expect an employee eating 6 Timbits to have 2.137 weeks of experience. So again, some talk about confidence. First thing you always check is your correlation coefficient, and because we're dealing with the same model, we can say this is a strong correlation. Which encourages my confidence in this result. Second thing we should consider is whether it's an outlier. So 2.137 is not only within the outlier bounds, it's also within the typical values. 2.137 is between this 1.157 and 3.043. So not only is it inside the outliers, outside the outlier boundary, it is within the typical range. So considering all three of those criteria, that it has not only strong correlation, it's not an outlier, and it's within the typical value for my data set, I am very confident in this particular result. The last example we're going to work out is how many Timbits do you expect an employee with 5 weeks of experience will be eating? So 5 weeks of experience, that's an X value. So back to my model again, one more time. Dropping in 5 as my X value. And I'll work that out, negative 2.71 times 5. It's negative 13.55 plus 11.791 it's negative 1.759. So according to the model, if you've been working 5 weeks at this Tim Hortons, then you are eating negative 1.759 Timbits per shift. Now that has a whole bunch of problems with it. But we'll start off just asking the normal question, how confident are you in this result? Well, the correlation coefficient hasn't changed, so we still have a strong correlation. But if I check this X value, an X value of 5, we said over here with the X's that anything bigger than 4.929 was an outlier. So this X is an outlier. And when you extrapolate into the outlier range, you're in very dangerous territory. It may be because you didn't sample enough people to get X's out there, or it could mean that the model doesn't apply here anymore. So because of that, I'm going to say I'm not very confident in this result, because I have extrapolated too far. The other thing we were checking was whether it was in the typical range, and obviously if it's an outlier, it is not in the typical range, so I'm not going to write that one down. But there is this other curious thing where I have negative Timbits. Question mark, furrowed brow. I'm not sure what a negative Timbit is an anti-Timbit or an un-Timbit. Timbits back from the dead. So I don't think this makes any sense. So this negative Timbit is a nonsense result. I think the closest to sensible interpretation of this negative would be that when this person shows up for their shift, they bring 1.759 Timbits with them, so that their negative consumption looks like production of Timbits. But even under that interpretation, I certainly hope that after 5 weeks of experience, your body doesn't start to excrete Timbits that then go on the shelf for people to buy, because I mean that's gross, unsanitary. So because it's an outlier, that's our first indication that I should not be very confident in this. The second is that it has produced a nonsense result.